Hi, I'm Jim Green, former NASA chief scientist and chief scientist of the MetaVisionaries. And tonight we have a wonderful opportunity for me to talk about a fabulous movie called The Martian, science fiction and science fact. And in fact, this particular movie was very popular. And in this movie, uh, Matt Damon starred, was produced by Ridley Scott, and they teamed up and called NASA wanting some help. And this is where I actually got involved in the movie. The movie is based on a book by Andy Weir. It's a tremendous story about an astronaut stranded on Mars and what will happen to him, whether he'll survive or die. So, without further ado, let's take a look at the trailer and get an idea of an overview of the movie.
Every human being has a basic instinct to help each other out. If a hiker gets lost in the mountains, people coordinate a search. If an earthquake levels the city, people all over the world send emergency supplies. This instinct is found in every culture, without exception.
At around 4:30 a.m., our satellites detected a storm approaching the Ares 3 mission site on Mars. The storm had escalated to severe, and we had no choice but to abort the mission. But during the evacuation, astronaut Mark Watney was killed.
I'm entering this log for the record. This is Mark Watney, and I'm still alive. Obviously. I have no way to contact NASA or my crewmates, but even if I could, it would take 4 years for another manned mission to reach me. And I'm in a hab designed to last 31 days. So, in the face of overwhelming odds, I'm left with only one option. I'm gonna have to science the shit out of this. Okay, let's do the math. I gotta figure out how to grow 4 years worth of food here on a planet where nothing grows. But if I can't figure out a way to make contact with NASA, none of this matters anyway.
Houston, be advised. We've got a video message. It's directed to the whole crew. Play it.
My God. Mark Watney's still alive.
Woo! In your face, Neil Armstrong.
We left him behind. Let's go get our boy. This is something NASA rejected. So we're talking mutiny. And if we mess up the supply rendezvous, we die. If we mess up the Earth gravity assist, we die.
It's space. It doesn't cooperate. I guarantee you that at some point, everything's going to go south on you. And you're going to say, this is it. This is how I end.
Is it possible that he's still alive?
Wow, what an exciting movie. And indeed, looks very realistic from many aspects. And fortunately, early on, Ridley Scott really let NASA know that he wanted to make as realistic movie as possible. And so this required a whole series of activities that we kicked in. The first one was a series of tours. So members of Ridley's team joined me at Johnson Space Center as we began the process of looking at control centers. How do we do things in space with the International Space Station, the commanding, and all the elements that require managing humans in space. How are the habitats? What do they look like? How are they configured? And so this was really quite a fun and wonderful set of tours that we did. We did it not only at the Johnson Space Center, where we showed the habitats and what NASA's thinking about that indeed has that look and feel in the Martian, where you have the round cylinder-shaped compartments that, of course, fit in rockets the best and get launched. They're connected, of course, in a way that makes the station look pretty cool. They did a fabulous job of making these things happen. And then, of course, we have the Watney Rover. This Watney Rover is based on what NASA's thinking is in roving both the moon and on Mars, as you see in the lower right-hand corner. What's exciting is indeed Ridley Scott took the designs of a number of things, including the inside of the cabin of the rover. So above the NASA rover on the lower right is the upper right, which shows the control panels. These are iPad-looking systems, touch screens, and indeed, Mark Watney's rover has some of the same characteristics indeed on the inside. Also, the spacesuits were quite exciting in the movie. NASA has, of course, these large extravehicular activity suits on the far left that we go out in and to repair and to build things in space. That was also very represented in the movie. But we're also working on a variety of designs for surface suits, as shown here by Ava Newman, who is working with NASA on these surface suits that are under development. And Ridley's team, Art Max, the set designer, designed a combination of the surface suit, as you see here, with the EVA suit to produce the surface suit in the movie that Mark Watney wears on the right-hand side. Really an exciting suit with all kinds of features that we would need on the surface of Mars to be able to operate and navigate and, of course, survive, because the atmospheric pressure on Mars is much lower than the Earth and the atmosphere is not breathable. In addition to that, what about the control centers? Here is a control center in the lower right that we reviewed at Johnson Space Center with Ridley's team. And of course, it's managing the International Space Station. That is reflected in the mission control in the Martian. In addition to that is also the orbiters. And many of the control features that we have at JPL, which is another location that we toured, have much of the same look and feel in terms of managing the orbiters. Those two control centers, one at Johnson Space Center that we showed them, and the other one at JPL, were combined into this beautiful control center you see that was in the movie, The Martian. Now, once you got down on the surface, of course, early on in the movie, there is this weather prediction system that they're all looking at on the movie on the left-hand side, looking at what's happening as the dust storm is overtaking them, and then making decisions on the fact that they'll have to leave. Now, what is the real case that we have in terms of global circulation models on Mars? It turns out we have some of the most sophisticated models running on our supercomputers at the Ames Research Center. And here is on the right-hand side, here is what these models are producing. So this is very realistic. You see Mercator projection of Mars in the upper right of the wind velocity. And so you see that the winds are very different depending on whether you're at higher latitudes or lower latitudes or even at the equator. And then you see what the wind patterns are around the Ares 3 station on Mars from the book. And so, indeed, this is very realistic. We'll have real-time observations from our orbiters that are providing this kind of information for the astronauts on the surface. And we have these global circulation models up and running right now. So, once again, very realistic part of the movie. Now, the dust storm that's portrayed in the movie, wow, looks quite severe, as you can see. And in fact, what happens is very different on the real Mars. The dust storms on Mars aren't anywhere near as severe. Now, even though the winds on Mars can be as fast as 125 miles an hour, and the wind then picks up the dust, which is like talcum powder. What it does is actually loft it high into the atmosphere, and that blocks the sunlight. And so the measurement of blocking the sunlight is called opacity. And so the opacity of the sky, which if it's clear, is close to zero. But over time, as you see here, it gets darker and darker, and then the opacity number goes up, and then that causes a complete blackout. And then, of course, the dust has to settle back down onto the surface, and it does that indeed in piles. We do see piles of dust. So you can see in the upper left-hand corner the pile of dust that filtered out at the end of the dust storm in the movie, with Mark Watney partially buried there. Very dramatic. But the real dust does that same kind of piling up. You can see here where Curiosity is moving between these dust dunes. The dust dunes to the right panel. You can see the wind patterns, the wind blown patterns of that dust. And indeed, they can pile up significantly. And Mark has to get out there and clean these dust panels off. And in fact, the same kind of things happen on Mars in terms of our ability to clean off the dust on our rovers. A new atmospheric phenomena was discovered. It's called dust devils. And you see in the upper left-hand panel the dust devils on Mars that are moving onto the surface. And indeed, from the bottom left-hand panel, which have the solar panels of the Spirit rover, which needed these panels to charge up their battery and operate, you see where the dust blows away. The dust devils blow away the dust that are sitting on the solar panels, and the rover then has the opportunity to charge up its battery and then continue on moving. This happened with Spirit and Opportunity and allowed them to work for many years beyond their lifetime. So this is also very realistic. Mark is having to get out there with these solar panels and clean them up. No dust devil has gone by. But indeed, in the movie, dust devils are shown. So you see on the right-hand panel, there's Mark walking on the terrain with beautiful dust devils in the background. Whereas the left-hand panel actually is one of the dust devils that go several kilometers up into the atmosphere, and you're observing this from one of the orbiters. So just some really spectacular scenes, not only in the movie, but that's exactly what was happening indeed on the surface of the planet. Now, one of the things I really enjoyed about the movie was the fact that it was a science mission. And indeed, we believe that human-enabled science will make significant gains. We can do some intelligent sample collection. And in fact, you see early on in the movie, Mark is out in the field, and he makes a selection of rocky material, and he puts that very carefully in a sample cup. He's also deploying instruments that are sitting beside him. This is really important in terms of making all kinds of measurements, not only wind and temperature and surface pressure, but also seismic measurements. We know that Mars has Mars quakes, and that's because of some of the seismic measurements that we made indeed on the surface. So human-enabled science is really important, and we're really looking forward to it. And the movie depicts that early on, of course, and that's an important element of the particular mission. Well, what do we have there today are an array of orbiters, and they're multinational. We see orbiters from the Indian Space Research Organization, which unfortunately recently came to an end. The MOM mission was operating for many years past its a designated lifetime. We also have the European Space Agency's Mars Express and the European Space Agency's cooperated orbiter called the Trace Gas Orbiter with the Russian Space Agency, also in orbit. Another fantastic orbiter is from the United Arab Emirates. Now, this is the HOPE mission that got into orbit in 2020 and is working wonderfully. It's still operating quite well. And in addition to that, we also have the Chinese Tianwen orbiter, which got into orbit in 2020. Now, China has also, with that orbiter, had an opportunity to land a rover. You see that down on the surface, along with the NASA rovers, Curiosity and Perseverance. As I mentioned, seismic measurements were made with the InSight lander, as you see here, but unfortunately, just the last several months ago, we also had to terminate that mission. And that was actually terminated because we had enough dust on the solar arrays that the InSight lander did not have enough power to charge up its battery and operate its instruments, but it lived well past its nominal lifetime. So we were really extremely happy with that. Now, in addition to Curiosity is the Perseverance rover and the Ingenuity helicopter. Now, this is the current array of capabilities that we have operating on Mars today. And in the book, and also in the movie, is portrayed a lot of these orbiters taking observations, looking down, seeing how Mark Watney moves on the surface, etc. And in the book, the assumption is that NASA would have 12 orbiters and the European Space Agency would have 2. Now, although we don't have that many, the new element of that today is the multinational orbiters that we have, as I mentioned, not just NASA, ESA, Russia, but also UAE and China. So just a tremendous array. Well, what does it really take to put a one-ton rover like Curiosity or like Perseverance down to the ground? So let's take a look at how this happens. So we'll go to now a simulation of the landings with one of our movies.
Jim, I'm having technical issues here with the projector, so better to continue with Perseverance.
Okay. So now, of course, what we want to know is much more about these beautiful rovers. Here is Perseverance. It's in virtual reality. It's really a spectacular rover. It's 1 ton. This is the current technology being able to put 1 ton down on the surface, when in reality, for humans, we're going to have to be able to put maybe 40 ton down on the surface. Well, we'll be able to do that, I think, in chunks. NASA currently believes that we could probably up the 1 ton delivery to maybe 10 ton. And so a 40 ton outpost would take 4 landings. The Perseverance rover that's down on the surface now is really highly capable. And the key element of the science that it's doing is taking samples, just exactly like what Mark Watney is doing on the surface is that kind of science. It's sample science. This is extremely important for us to be able to determine the evolution of the planet, what's happened over time, and of course, have the opportunity to look for life. Life is in the rock record if it's survived for long periods of time in the past, and indeed that's enabled life to live and die, and then over time, literally become part of the rock. This could be found by looking at the mineralogy of material in the rock, and of course by coring it, we can bring it back and then really take a good look at it. So at the end, we're going to come down and take a much better look at at all the features that this rover has, and I'll be able to answer all your questions about what NASA is doing in this area. And one of the wonderful features this rover has that the movie leverages is radioisotope power. Instead of the solar panels that Spirit and Opportunity have had, and also Insight, where the dust can accumulate on these solar panels, prevent them from charging up the battery and allowing them to operate the instruments. What we use is plutonium-238. Now, this is a wonderful isotope. It flies apart, creating all kinds of energy from the motion of the nucleus that breaks apart. That's what radioactivity is really all about. It mutates material from one type into another, and by combining that and putting it in a system of called a radioisotope thermal generator, we then can heat up a thermoelectric, which gives a voltage difference in that material, allowing us to move a current, charging up the battery, and then we run everything off the battery. Just like we do on Spirit and Opportunity, instead of using the solar panels, we use this hot material, this radioisotope power material, to be able to do that. That is in this, indeed, this back part of the rover. You see it here. It has a fan-like shape because it's also dissipating heat. It also has a distribute that energy to heat up the interior of the rover. Now, what we also see in the movie is indeed Mark Watney needs that heat in his rover, the bigger rover that you saw earlier. But this is not to power the rover necessarily. It's really used to power generate the heat necessary to keep him alive in an environment that can be extremely cold. The nighttime on Mars can be well below 70 or 80 degrees Fahrenheit. Now, another one of the experiments on Perseverance is called Moxie. This stands for Mars Oxygen In Situ Resource Utilization Experiment. Here's an open view of it. It's not very big. It's designed to take in Martian atmosphere, which is primarily carbon dioxide, zap it with a little electricity, and then break it apart. Give the atoms enough energy for them to break their chemical bonds, allowing then the oxygen to recombine into O2, giving you at the end of that process carbon monoxide and oxygen, O2. The O2 you then can breathe. You can vent the carbon monoxide, and you can determine how much oxygen you can reap out of the atmosphere in this process. And it turns out it's really pretty significant. In fact, Moxie makes 6 to 10 grams of propellant-grade oxygen per hour. This is enough oxygen, of course, that you can even breathe. So that is also an important element. You can make rocket fuel because you can make the oxygen, the O2, but you can also breathe that. Now, this is called Moxie on Perseverance, but in the movie Martian, it's called the oxygenator. So, indeed, that's another experiment that was on this particular rover, which even before the movie was released, we were developing and getting it ready to go, but it hadn't landed yet. The movie portrayed it very well as indeed the system that extracted air, the breathable air out of the atmosphere of Mars. So another part of the movie that was well done and quite accurate. Now, here's a Mercator projection of Mars where you see all the landed assets that have occurred that for long periods of time. We have Phoenix, Viking 1, Pathfinder, Opportunity, Spirit, Viking 2, Insight. Those have been operating for a number of years. They're no longer in operation, but you can see where they have landed on this Mercator projection. And then, of course, Curiosity, Perseverance, and Zhurong, which is the Chinese rover, is indeed also on the surface of Mars at these locations. Now, this Mercator projection is also colored. The topography is colored in a beautiful way because the reds and the whites are the highlands, and the blues and the greens are the lowland. And you can imagine in the past where water and Mars had a significant amount of water in the northern hemisphere. It was in this blue area. And in fact, the green area as depicted here is actually the ancient shoreline of Mars. So 3 billion years ago, Mars had 2/3 of the northern hemisphere underwater, and in some places as great as a kilometer and a half, on the order of a mile or more. So really spectacular. Now, indeed, that shows us that many of our missions land in the green area, which is that ancient shoreline that gives us an opportunity to really look for life. Now, where's the Ares 3 landing site? Well, you see here, it's that out in the middle of the ancient ocean of Mars, north of Pathfinder. And of course, also ExoMars is the upcoming ESA rover that will land in this particular location. And in the movie, Mark Watney moves from Ares 3, that's where the human station is at, all the way down to Pathfinder to be able to get communication capability that he will resurrect the Pathfinder rover and get it operating. Now, of course, we don't think that's realistic to do, but indeed, the movie magic is his ability to get it up and running. But he does find it. He does go down and find it. And of course, it's already significantly covered with dust, and he pulls it out and then brings it back to the Ares 3 station. Now, that's very reasonable. One can expect that indeed may happen. Well, what does this area look like where the landing site is? The location is well described in the book and depicted in the movie. It's a place called Acidilia Planitia. Okay, Planitia meaning lowland. And indeed, what we've done is taken some high resolution imaging. You can see the image strip on the left-hand side. We've blown up exactly where the Ares 3 base would be based on the coordinate system. And then in the movie in the lower right, you see Mark sitting off to the side, looking over to the habitat on one of the crater rims. And so indeed the site that they picked in Jordan when they did the Mars scenes were indeed very, very realistic. So indeed, the look and feel even of the area of the landing site was done quite well. Now, one of the exciting things about the movie is, as you saw in the clip in the movie trailer, Mark Watney, for him to be able to survive means he's got to be able to grow food. He uses the potatoes that were brought on the voyage that were going to be used for Thanksgiving dinner, based on their landing time, would encompass the November Thanksgiving holiday. And that's very realistic. There is an opportunity in the 2030s where exactly that happens. And he then creates the crop that you see depicted in this particular picture. So what really is that soil like? Is it such that you can actually bring in Mars soils and really take a look at this farming issue as a realistic activity? Well, for us to be able to answer that, we're going to go to one of NASA's rovers called Curiosity. So here's an image of Curiosity in an area. This actually is a crater called Gale Crater. This is an area that had a significant amount of water for long periods of time. In fact, the terrain looks like there's mud flaps here, that have now all dried. And so it has the red patina of the oxidized surface, and Curiosity then bores a couple holes just below the surface, just below this red patina. You see gray Mars. Okay, so we then scoop that up, bring that indeed into the rover and taste it. And we understand what the composition of that material is. And we're finding out that the key chemical ingredients, carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur, are all there. All the things necessary for the chemical ingredients for life. The soils are moist and they have nitrates, which means there's a little bit of a fertilizer in the soil in a natural way. So this is really tremendous, and bodes really well for the movie. Okay, let me answer the phone. Okay, so getting back to this fabulous set of observations in bring soils into the habitat and use them. Now these soils at where Curiosity is are alkaline; they're not acidic. Potatoes grow better in acidic soils, but we're sure there's probably acidic soils elsewhere on Mars. Now, there's also some toxic chemicals, perchlorates, that have been discovered, but they're not everywhere, and they can easily be leached out with water. So we believe then, indeed, given the right chemistry, you can bring in soils from Mars, and indeed, they have all the micronutrients and macronutrients necessary to grow plants on the inside in a beautiful greenhouse, as shown in this particular example. Well, one of the other things that Perseverance has is a fabulous little new instrument, not depicted in the movie or in the book, but certainly something that will be important for future exploration on the red planet, and that is a helicopter. This is our first attempt to be able to fly, indeed, in the Martian atmosphere. And Ingenuity hitched a ride underneath the rover. It had It was covered with a belly pan that we dropped, as you can see in the lower left panel. Then the rover was, sorry, then the helicopter was deployed below the rover. Then the rover moved away, and we actually can see what happens when we turn on the helicopter. And in fact, it's made over 40 flights. But we're going to show the 10th flight and how that goes. We take off in an area, but we also can make some really important moves at certain waypoints, or we can dwell a little bit, taking a look at indeed these beautiful beautiful features. Now, this is coming from the downward-looking camera on Ingenuity as it's flying by the terrain. There's actually quite a ridge of rocky material that we we looked at, and then we moved away from that area and found a landing spot, and indeed set down safely on the surface. This is pretty spectacular and shows the tremendous capability of the helicopter. So the Ingenuity is quite versatile. As I mentioned, it's already made close to 40 flights. Here it is depicted in virtual reality. And it is indeed about the same size as you see here, just like the rover is to the same fidelity as you would see in real life based on the size of our avatars, if you were able to walk up and take a look at it, which we will do here soon. What our future is, the potential of flying on Mars will be that it can go to places that we can look at, like caves or collapsed lava tubes, as depicted here, where the helicopter can go down, make measurements, can do imaging, temperature, pressure, humidity measurements, looking for microbes, looking potentially for life that might be hidden in the crevices, might be viable on the subsurface of Mars. And this little opportunity with the flying machine on Mars might be able to reveal some of these exciting elements. Now, NASA, unfortunately, is thinking about only one site, rather than the many sites that are in the movie and in the book, where each crew lands at a facility and roams around. And this is why Mark Watney, which is trapped in Ares 3, has to move to Ares 4 to get a new Mars ascent vehicle to return home in. NASA's planning to have one area, and we'll go back and forth to that area over and over again. It's called an exploration zone. It's about 200 kilometers in size. The plan is we'll land in one area, we'll live in another area, we'll do science investigations by taking our rover, going out tens of kilometers or even more, 100 kilometers or up to 200 kilometers, and deploy instruments and make measurements. But we'll also use some of the minerals, perhaps for 3D printing on the surface. We'll certainly be able to grab some of the soils, bring them in for into these greenhouses, as I mentioned, for food production. And so these resources will be extracted and used from the surface. So really an upcoming, really exciting time for exploring Mars into the future. Once again, similar to what was planned in the movie The Martian. So many of these plans are the same, but some of the details, of course, as I mentioned, are different. Well, thanks very much. As you can see, the movie was very realistic, had beautiful scenery. Much of the science and activities that are done were realistic. And now we have an opportunity to come down. I invite all in the audience to come down and join me in and around the rover, where we can talk about some of the fabulous features. Thank you very much. All right, this is about to scale. Yep, indeed, it's got the drill is right here down on this particular end. It also has a laser breakdowns spectrograph that allows us to take a laser, pit rock, take a spectrum of it, and really understand what it's like. As I mentioned here in the back, here's the radioisotope power system. This particular power system, it has also the generates 2,000 watts. A lot of that goes into the heat, then goes into the rover. It's done through these yellow lines. It has a couple major antennas. It has this antenna, which actually is a Ka band antenna, and this antenna, another Ka band antenna. This is a wide dispersed emission of radio waves, whereas this is much more focused and is used for commanding. So we can send commands to the rover through the Ka band system. When we take data, and a lot of this data, we actually use the antenna that's in this black box right here. It's a helical antenna. And as the rover gathers observations, assets fly over. Indeed, the satellites fly over, and we beam up the observations that are made by the rover. And then, of course, the weather station on Perseverance and on Curiosity is right here on the mast. These arms that stick out actually are making temperature, pressure, and wind measurements. A fabulous instrument actually comes from Spain, and so that works well. Here is our landing movie. What it takes to put a 1-ton rover down on the ground is a significant amount of work. You drop a heat shield after you go to a chute, and then you actually drop the rover itself, as you see here. And it powers itself down to the surface to what we call the sky crane. This is a system that's a shell. It's over the rover itself and get about 20 meters off the surface. To the surface, then indeed set it down softly on the surface. And once that's accomplished, what will happen next is information about safe landing occurs, the line is broken, the sky crane flies away and crashes, and then we have the opportunity for the rover to get started and make its measurements. The mast comes up, and then the experiments begin the process of making really exciting measurements on the surface of Mars. And one of them, of course, is the LIBS instrument, this laser breakdown spectrometer. Here you see it working. You zap this laser, hitting this rock. The rock will smoke from the heat that's generated by the laser breaking down the chemical bonds of the rock, and then we take a spectrum of it, and that gives us a great idea as to the composition. Once we have the composition, then we can understand a little bit about the mineralogy, indeed, of the rock. Now, also on the inside of the rover is the Moxie instrument. So that's sitting right here near the mast, inside the rover itself. Okay, any questions I can answer that you may have? All right. If not, thanks very much. I hope you enjoyed traveling with me to Mars and seeing what it's like and really getting a great view of how well the movie is done. And I'm sure that will help you understand what the real life is like on the surface of Mars. Thanks again.
That was
Bye
great,
now.
Jim.
We move layers in silence, leave it all behind us. Meta visions are flying to galaxies unknown. In space, we
It's really good to see the screen actually. Dude, loved it. Really loved it. I think it's going to really, channels are going to really respond. So much multimedia, right? You know what I mean? Yeah, it's great.
New frontiers can open our minds. No, we're not so far.
Okay, well, what I suggest is let's pop on Zoom and talk about what worked, what didn't work, and
Running at the midnight, white lights,
what we can do in terms of.
until the twilight, the bright skies, supernova, up to the moon, we will go beyond our reason tonight.
So here's New Horizons.
Burning the fire, watching me fly higher, across the entire.
And here's Hubble.
But I still never found my feet to the ground. And I'ma be dancing on my eyes to build on, cause you know we're breaking the speed of sound. Fly, fly, we fly.
Yeah, Camilla, the
Yes, sir.
New Horizons spacecraft is huge, way too big. It's more like a grand piano in size. It's not as big as yeah. So that's too big. It needs to be cut down by a factor of 2 in size.